Hello, 5th grade. Today we're on lesson 81, and if you have your book, we're on page 526 and 527. We have three objectives. First, we will reduce fractions by dividing by fractions equal to 1. We will determine if a fraction can be reduced, and we will write the probability of an event as a fraction in lowest terms. I think in lesson 79, we talked about changing fractions by multiplying them by fractions equal to 1, and that was just like showing that 1/2, if you multiply it by 3/3, a fraction equal to 1, you can get it to look differently, and usually if we want to add fractions, we got to find a similar denominator. So that's one reason that we might multiply by a fraction equal to 1. 1 times 3 is 3, 2 times 3 is 6. This fraction and this fraction are equivalent. They're the exact same thing. However, they look a little bit differently, and we can do different things with this fraction now that we've changed it. Now, sometimes you're going to get an answer and we'll want to simplify it. We'll want to make it as easy as possible. In the book, they talk about reducing those fractions. Okay, reducing means to make something smaller. We're not making the fraction smaller when we go from 3/6 to 1/2. Okay, but I guess we're making the terms smaller. So the number 3, the numerator becomes a 1 when we divide both terms by 3. Okay, so 3 divided by 3 is 1, 6 divided by 3 is 2. When you multiply by a fraction equal to 1 or divide by a fraction equal to 1, you don't change the value of the fraction, you just change the way they look. And so they use the term reduce. I'll usually use the word simplify, because literally we're not reducing the amount the number represents, we're just making the number smaller, the term smaller. We are on page 527 and example number 1. So make sure we write this on our little sheets. Example number 1 says reduce the fraction 6/8 by dividing both the numerator and the denominator by 2. So when we divide, we want to divide both the numerator and the denominator by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So our reduced fraction is 3/4, and that's the answer that you'll write down for example number 1. Now, this fraction, 6/8, and this fraction, 3/4, they are equivalent. They represent the same value, and I'm going to show that just by drawing a picture. Okay, I'm going to split it up into 4ths and then 8ths. And over here, I'm going to split it up into 4ths. It's not going to be perfect, but it should be pretty close. And here we can represent 6/8, and here we can represent 3/4. And you can see that there's a very similar amount of unshaded parts on both of these. Now, we've divided by a fraction equal to 1, so we've changed the way it looks. We've simplified this fraction, but we haven't changed its actual value. If you cut a pizza up into 8 parts and you have 6 of them, it's the same amount as if you cut a pizza up into 4 parts and then you have 3 of them. Obviously, those are big pieces. All right, now on the next page, we've got some more fractions that we're going to simplify. It says, for example, 2. Not all fractions can be reduced. Only fractions whose terms can be divided by the same number can be reduced. So, for example 2, it says which of these fractions cannot be reduced. And it has 2/6, it has 3/6, C is 4/6, and D is 5/6. Okay, so if these two numbers share a common factor, then they can be simplified. They can be reduced, as the book would say. Okay, 2/6. They're both even numbers. They can both be divided by 2. So if we wanted to, we could simplify 2/6 and by dividing both terms by 2. Okay, we're not actually dividing by 2 halves. We're literally dividing the numerator and the denominator by 2. And 2 divided by 2 is 1. 6 divided by 2 is 3. this fraction can be reduced. The question was which fraction cannot. 3/6, we know right off the bat that 3/6 is equal to 1/2 because the numerator is exactly half of the denominator. Therefore, that one can be simplified. 4/6, again, we have two even numbers, so both terms can be divided by 2. 4 divided by 2 would be 2. 6 divided by 2 would be 3. Our fraction would be 2/3. 5/6 is your answer for example number 2. 5 and 6 share no common factors aside from, of course, 1. If you divided both 5 and 6 by 1, we'd end up with 5/6. We wouldn't simplify anything. So again, your answer is D for example 2. And example number 3. Example 3, it says add 1/8 and 5/8, and then it says reduce the answer. Again, we're simplifying our answer. 1 plus 5 is 6. Our 8, when we add fractions, our denominator, they're the same and they remain the same. And now we have 6/8. We need to simplify this fraction, 6/8. Okay, a good starting point is to just start by dividing by 2 if they're both even. So I'm going to divide both terms by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Because 3 and 4 share no common factors aside from 1, we have a completely simplified fraction, 3/4. And that's your answer for example 3. Okay, example 4. We've got a story problem. It says Caroline has a box of beads that are all the same size and shape but are different colors. The box has 4 red beads, 6 yellow beads, and 20 blue beads. Without looking, Caroline chooses 1 bead from the box. And it says, what are the possible outcomes? So 4 reds, I'm going to write down the information that we're given. 6 yellows and 20 blues. And these again are all the same size, so it's going to be totally random. What are the possible outcomes? Well, for your answer, for example 4, okay, it's a 2-part answer. Part A, the possible outcomes. Well, she could either pull a red, a yellow, or a blue bead. And those are the 3 possible outcomes. Okay, for part B, they ask us, what's the probability that the bead Caroline chose was blue? So what we do is we use the number of blues that we have, and we put it over the total number of beads that we have. And because 6 and 4 is 10, and we add that to 20, there are 30 total beads. So there's a 20 and 30 chance that she's going to pull a blue bead. Now we, of course, are simplifying this lesson, so we want to simplify this. Yes, both of these are even, so we could divide it by 2. We could divide each term by 2, and 20 divided by 2 would be 10. 30 divided by 2 is 15. Okay, they still share a factor. They still share the factor 5, and 10 divided by 5 is 2, and 15 divided by 5 is 3. Our reduced fraction, or our reduced ratio, is 2/3. Okay, another way you can reduce these two numbers, 20/30ths, okay, is find the greatest common factor that they share. The greatest common factor of these two numbers is 10, and you can see that they both end in 0. A quick and easy way to divide by 10, remember, we can get rid of those zeros. So our answer is 2/3. Okay, and whether we're dividing by 2 and then 5, or just dividing by 10 right away, our outcome is the same. All right, the final example is example 5. And that example is 5 and 5/6. And we're taking away 2 and 1/6. Okay, when we subtract these fractions, we subtract numerators. 5 minus 1 is 4. Our denominator remains 6. 5 minus 2 is 3. Okay, we have a mixed number, but simplifying the fraction portion of it, the rules remain the same. We just divide by a common factor. They are both divisible by 2 because they're both even. I'm just going to carry over my whole number 3. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 and 3 share no common factors, aside from 1, and therefore we are finished simplifying example number 5. All right, and that is the end of today's lesson.